So let us see question number 3.05 from GATE 1991. It's a 2-mark question from XRD. The wavelength of K alpha radiation is shorter than K beta radiation. So we should say whether this particular statement is true or false. Okay. To say whether it is true or false, first of all we should know what is K alpha and what is K beta. Okay. For that, we need to go back to our X-ray generation basics. If you can remember how the X-rays are generated. When a high energy beam hit the target material, let's say some copper or iron or cobalt, right? So, like for every element, copper also, I mean there is this particular target also will have some nucleus and some orbits, right? We know this is a K shell and this is a L shell and this is a M shell. So let's say this high energy beam, I mean the electrons from this high energy beam have enough energy to knock off some of the electrons from K shell, right? Then what will happen? A vacancy will be generated here in K shell, right? So obviously a higher energy electron will try to come to closer to nucleus, right? So that means an electron from L shell can come to K shell, or an electron from M shell can come to K shell. So the radiation generated from an electron coming from M to K is called as K beta, right? Whereas the electron is coming from L to K, that is called as K alpha, right? L to K. Whereas the K beta will be M to K. If you can see, these shells have different energy, okay? So the K beta energy will be more when compared to the K alpha, because there is a large gap, right? So you need more energy for an electron to come from M to K, right? So that means, if you can remember this A is equal to hc by lambda, if you have more energy, you will be having a less wavelength, right? I mean a shorter wavelength. That means the K beta being a more energy radiation will have less wavelength, I mean shorter wavelength. So your K beta will be having a shorter wavelength than K alpha. That means this particular statement is wrong, because K beta will have a shorter wavelength than K alpha. So if you can remember our characteristic X-rays chart of intensity versus lambda, you can remember this is actually the K beta and now followed by K alpha, right? So this is K beta and this is K alpha. So you can see the K beta will be having a shorter wavelength than your K alpha. Okay, so this particular statement is false.